Okay, so we're going to continue here with lesson 3.1, and this is on page 73. They took the information from the previous problem where they had distance in leagues and distance in miles, and they plotted the points on the quadrant 1 or coordinate plane. So here you can see that 1 league is 3 miles, 2 leagues are 6 miles, 3 leagues are 9 miles. And when you look at a graph, if you want to know if it's proportional, the only thing you have to look at is the origin. If a line passes through the origin, then it's going to be proportional. So that's the key when you're given a graph to see if it's proportional. Okay, and here's example 2. This is a graph that shows the weight of an object on Earth and the weight of an object on the moon. Here you have, this is your x-axis, and this first number is always x. So you have the Earth as your x and the moon as your y. The y-axis is always vertical, x-axis is always horizontal. Find the constant of proportionality. Well, that's when you take the moon weight over the Earth weight. So when you find the constant of proportionality, it's almost like you flip these two. The y was on the bottom here, but it's on the top now. That's how you find your constant of proportionality. Then you just take the numbers and write them down. Simplify as needed. The constant of proportionality is 1/6, so you can write an equation. Now you want to let x represent the weight on Earth, which you have to say that. Let y represent the weight on the moon, you have to say that. And then that's going to be your constant of proportionality, and that gives you your equation. Also notice this is proportional because it goes through the origin. Okay, I apologize for this being so blurry, but it's the best I could get it. This additional example is not in your book. The graph shows the relationship between the number of days a car is rented and the total cost for the rental. Write an equation for this relationship. So keep in mind that your equation is y equals kx. And the y and the x are simply the points that are on the coordinate plane. We need our constant of proportionality. So let's pull some points. So here, I can see that that is 3 for the x and 100 for the y. So whenever you're trying to find your fraction, your y goes on top, your x on the bottom. Here's another point. And that point is going to be 6 and 200. And once again, your y is on the top. Oops, that was ugly. Your y is on the top and your x is on the bottom. And let's just pull out one more. Let's pull out this one. And that's going to be 0.12 and 400. And that'll be 400 divided by 12. So when you go through these and you simplify them, this is going to stay 100 over 3. This is going to become 100 over 3. And this will become 100 over 3 because you divide those all by 4. Okay, so now what does that give us? Well, our constant of proportionality here is 100 over 3. And you can put that in as your k. You can put in y equals 100 thirds x. Or if you wanted to just simplify 100 over 3, it's going to be y equals 33 and a third x. It doesn't matter which way you leave it, either one of them is equal. Okay, your turn. This is where I just give you a chance to figure out these answers. It's okay to make a mistake, because that's how we learn. So try 4 and 5. So here's your solutions. What does the 0.56 represent? So here's 5 and there's 6. So 5 is time in hours and 6 is distance in miles. So it means in 6 miles height in 5 hours. What is the equation of the relationship? Y equals 6/5 x. So I didn't really know how to type that in. So that's the fraction 6/5. So that's why it has that slash in it. So your constant of proportionality is 6/5. And you can get that from any of these points. Okay, now we're on page 74, and this is part of the guided practice. And so complete problems 4 and 5, and I'll be back. Okay, so for the first one, I completed the table because that's what the instructions said to do. And go from oxygen to hydrogen, 2 to 4, I must have multiplied by 2. 5 times 2 is 10. 17 times 2 is 34. 120 times 2 is 240. Then I took each of those sets and I put them as a fraction. Remember that when you make them into fractions to find their constant of proportionality, it's going to be y over x. And x is the atoms and y is the hydrogen. Keep in mind that the x is on top for the table. However, when you're looking at the fractions to simplify, the x is at the denominator. So each time the constant proportionality was 2, that's my k, so y equals 2x. So when I choose a number for x, like the 5, I plug a 5 in for x, 2 times 5 is 10, that's my y. For problem number 5, I just simply took these ordered pairs, these points, and I made them into the fraction. So 1 is x, 30 is y. There's my x, there's my y, it equals 30. 2 is x, 60 is y. My 2x, my 60y, 30. 3 is x, y is 90. 90 divided by 3 is 30. So 30 is my constant of proportionality. Y equals 30x. Okay, so try this essential question. If you know the equation of a proportional relationship, that is, you know the equation is y equals, let's say, 3x. You know the equation, that's just a sample. So you know the equation. How can you draw the graph of the equation? So think about that for a minute. Okay, so use the equation to make a table. So you can use the equation to make yourself a table. So this will be your x value, your y value of whatever it is you're dealing with. I don't have a story for this. So you choose a value for x, and to find y, you would just plug this in. So y would equal 3 times 1, can replace 1 or x with 1, so y would equal 3. Now I'll use a 2. So make this a 2. 3 times 2 would give you 6, and so on and so forth. Okay, so once you get that done, get rid of this. Once you get that done, you now have these ordered pairs. So you would have your coordinate plane. Find a place here for my coordinate plane. I have 1, 2, 3, 4, 1, 2, etc. And then you would just take those ordered pairs and you'd plot them for wherever they would be and take a nice straight edge and make your line. That's what you would do. And that's what you're going to do.